So going on to the next example, we've got a greater than sign. Okay, so think we're going to shade above the line, and there's no equal sign. So when we draw the line, it's going to be dotted. So again, if it helps, think about it just as an equation. We know the intercept is -2, so it's going to hit the y-axis here at -2, and the slope is a positive 1/4. It's going up because it's positive, up 1 over 4, and we're going to make a dotted line. So up 1 over 4. The next coordinate is not going to be on the graph, so let's go backwards. Instead of up 1 over 4, down 1, left 4. There's that point. And when we go to draw this, it's really easy to just get in the habit of drawing that straight line. Solid, but this is going to have to be a dotted line. Okay, it's dotted because it just says greater than. It is not part of the solution set. So only everything greater than this line is part of the solution set. And so it's pretty obvious on this one. That would be all of this region. So any point, any ordered pair, so 0, 0, is going to make this true. Think about it. Here's 0, 0. Should be part of the solution set. Plug it in for x and y. 0 and 0. This 0, when you multiply times 1/4, makes it go away. And so all you're left with is a -2. This y became a 0. So it says 0 is greater than -2. Well, that's a true statement. Okay, so this point of 0, 0 makes it true. And that's going to be true for any set of points that you pick up here. If you picked a point that's actually on this line, it's going to make it untrue because it's not included. And if you pick a point that's in the non-shaded region and plug it in for x and y, it's also not going to work. All right, let's look at one special case down here, and then what happens when we have an equation that's not in a nice form. So starting here, it's first of all says less than. Okay, so we're going to be shading underneath of this line, and there is an equal sign there, so it's going to be a solid line. So think if this just said y equals 2/5 x. It does not appear to have a y-intercept, but it technically does. It's like a +0 being out there. So the y-intercept is 0. It's going to hit right in the middle of that graph. So if there's no plus or minus, our intercept is 0. It's a positive 2/5, which means we're going up 2 over 5. And if we want to go backwards 1, down 2, 5 this way. Again, it is included because of the equal sign, so we can draw a solid line. Anything on this line will work for this inequality. Take 0, 0, for instance. Plug them in. 0 on this side, when you multiply, it gives you a 0. You already have a 0 on this side, so it says 0 is less than or equal to 0. So it's the equals to part that falls on this line. Now, it says y is less than, so all of the rest of the solution set is less than or underneath this line. So any point in this shaded region is going to work if you plug it in. Okay, let's go to this last one now. To put this on the graph, the easiest way to do it is to have one that's in this slope-intercept form. So what we're going to do is we're going to go ahead and we're going to take this, and we're going to have to solve it for y, so that it says y equals, and then it looks like the rest of these, and we've got a nice slope and intercept. So we're going to take 2x minus 3y. I'm just going to bring it down here. So I've got some room to work with. I'm going to solve it for y. So minus 2x. And then all I got to do is divide by -3. Now I want to stop you for a second and remind you, when you're working with inequalities, if the number that you're dividing by is a negative, think about what you have to do. You have to flip it. So that doesn't change. That's still true here. So this cancels, and I still have just y now by itself. Since I divided by a negative, this must flip the other way. And think about how important that is. Here, it's going to tell us to shade the exact opposite region. So if you forgot to flip it, you're going to end up shading the wrong part of the graph. 2 negatives over here do make a positive. So it's 2/3. Oh, and I had forgotten over here the plus 12. Some of you are probably thinking, what happened to the 12? So it was a negative 2x. We still need that plus 12. All of it gets divided by 3. So over here, two negatives make a positive 2/3 x. Now this is plus, but when we do 12 divided by negative 3, that's negative 4. So we're going to minus 4. And now we have an equation or an inequality that we can work with. Here's our slope, and here's our y-intercept, negative 4. So I'm going to go to negative 4 and put it on the graph. I'm going to use my slope of 2/3 up to over 3, up to over 3. Go the other way, down to over 3. Notice I made a solid line because there is an equal sign here. Even if it flips, that's not going to change. I still have the solid line because the equals is there. And now I got to choose, am I going to shade underneath or am I going to shade above? Where's the solution set? So if you just looked at the original and you saw y on this side and you saw open towards y, you might initially think it's going to be above. But you can always double check. If the coefficient of y has a minus in front of it or it's a negative, you know you're going to end up dividing by that number. We ended up dividing by negative 3, which flips it. So if you're going to check at the beginning and start thinking ahead, is this going to be shaded above or below? All you have to do is look at the coefficient of y. If it's negative, this is going to flip and it's going to end up saying less than, and that's what happened. Okay, so you can even understand that ahead of time. You don't have to go through the whole process to see that. But y is less than, and so the region that we need to include in this solution set is completely underneath.